Yes, good afternoon to all. Hello. Good afternoon to all.
Good afternoon, ma'am.
Good afternoon, ma'am.
Beta Diba, are you ready?
Yes, ma'am.
Most welcome, sir. I'm Dr. Archana
Thank you, ma'am.
Shirbakar.
Thank you,
Okay,
ma'am.
sir. Okay, Diba, please start.
Yes. Good afternoon, sir. Good afternoon to the students, teachers, and staff members who are present in this meet. We are very delighted and honored to have Mr. Sachin Purushottam Jolhe today with us. He is working assistant professor, Department of Electrical Engineering, Government College of Engineering, Nagpur, with an experience of 17 years. He has done his qualifications are Bachelor of Engineering, ME, and is pursuing a PhD currently. Alongside, he has also published many journals and also presented the papers in national and international conferences. Uh, we the students heartily welcome you, sir. Please,
Thank
you
you.
may proceed for this session.
Thank you. I'm really thankful to the Anjuman College who had given me the opportunity to uh, teach you this subject. Uh, just now we are going to start with the this is our topic. Okay, so today I'm going to discuss these points in this lecture. First, we have to see the Gauss-Seidel and Newton-Raphson load flow method, voltage and frequency control, power factor correction, symmetrical components, symmetrical and asymmetrical fault analysis, principle of overcurrent, uh, differential and distance protection, circuit breakers, system stability concept, equal area criteria, and the system stability. These are the topics of today's lecture. So we will see it one by one. Now, this is actually the figure uh, which you have studied in a third year. This is over the power system. This is a single line diagram of the power system. This is the generating station where we can generate the 11 kV. Normally generation it is 11 kV, not more than that. But nowadays whatever the generator it is there, it is going to generate the higher voltage. As the voltage is increasing, some other parameters are also going to be uh, some problem. And we are actually dealing with the, as the voltage is increasing, there are the some parameters which we have to consider. Then it is to be step up normal, it is there, then primary transmission, then secondary transmission, then primary distribution and secondary distribution. Normally we are at this position where we are getting the three phase outside our house, and out of that we are using a single phase 230 volt 50 hertz supply. Now, as an electrical engineer, we have to see how the electricity is flowing, and we have to calculate many things, and depending on that only we can able to get its maximum efficiency, means economic dispatch. Nowadays it is called as the economic dispatch, because the economy is a very important thing. We can able to calculate the what is the load, or as well as we can say what is the mm, uh, short circuit current and other things. Whatever we have to calculate on the in this system is called as a load flow analysis. So we will study. We have to study this load flow analysis. This is actually the main part of the power system. This is one may say this is a bread and butter for the electrical engineer. Then the information obtained from the load flow studies are magnitude of the voltage and its angle, real and reactive power, and line flows of Pij and Qij. There are the different models. When we have to do these things, we have to model it. For a short line, it is a very short line, it is there, and so we can call it as a short line, means up to the 50 kilometers we are going for that, 50 to 100. Then afterwards we are using the pi model, and then if the line is huge, then normally we are using the T model. But nowadays we are not going for the T models also. uh, can anybody tell whether my presentation is visible or not, properly visible or not? Is there any problem in presentation? Hello?
Yes, sir, it is not properly visible.
Okay, wait a minute then. Now it is visible.
Yes, sir.
Okay. Okay, so there are the two different models are there, pi model and T model. But normally we are not going for the T model, because in a T model, what we are doing, we are lumping all the capacitance and we are putting the one only, and we are distributing the reactance. So, the inductance we are actually uh, dividing. As we are dividing the inductance, it is very much easy to calculate the thing. But there is one major point in that, it is having a node. As there are the nodes are there, then it is going to have some problem. It is going to increasing the calculation may increase karta hai. So what we are actually doing, we are actually trying to reduce everything, and it should be very much easy for the calculation. So we are normally going for the pi model. In a pi model, there is no node, it is there. It is called as a node. So uh, major times we are using this pi model. Then there are the different methods are there to analyze how the this power it is flowing, or we can able to calculate the different parameters of the power system or the load. This is called as a load flow. So was it is there, it is the Gauss-Seidel method, then Newton-Raphson method, fast decouple method, fast decouple method, and direct current load flow method. These are the four methods. We will have to see only two, Gauss-Seidel and Newton-Raphson. What is the Gauss-Seidel? The Gauss-Seidel, it is the one of the method. used to solve the linear system equation. This is iterative. Iterative means there should be a loop should be there. एक कोई सा तो भी लूप रहना चाहिए so that we can लूप रहेगा इसमें मतलब एक ही चीज हमको 3 बार देखना पड़ेगा वैल्यूज चेंज करके and we should able to get one answer that is called as a iterative. So in this method it is nothing but the iterative method. This is named after the scientists Gauss and Seidel. This method is iterative for solving the n-linear equation with the unknown variable. This modification reduces the number of iterations. This is invented in 1823. It's very long back, near about 200 years back. So still it is used. But at that time, that commercial electrical distribution is not started. So this is not purely made for our electrical. और इलेक्ट्रिकल के लिए कुछ बनाई गई ऐसा कुछ है नहीं लेकिन ये मैक्सिमम टाइम we are using it is for the calculation of electrical load flow. What are the advantage of this? It is the simplicity, simple technique. It is there, small computer memory requirement, less computational time per iteration. These are the 3 advantage of this. Limitations, it is the slow rate of conversion because as it is going to get the iterative thing means we have to use the n number of the iteration, and for iteration also we have to form a one formula, and that formula also to calculate the anything it is taking some time, so that also it is slow down the rate. And many times it happen also in this we have to guess something. Initial जो points है we have to guess the initial points, initial coordinates. Initial coordinates, as we have to guess, if it is very much away from whatever the results are there, then it cannot converge, means you cannot get the result out of this. This may happen with the with this system. This is also there. If the matrix is diagonally dominant, then only it is going to convert. Otherwise, also it is not possible to convert or the converge to the or coming to the one result. Then, as the number of buses is going to increase, there are the these equations are going to increase. As the equations are going to increase, then the variables are going to increase. As the variable are going to increase, there are the iteration it is going to increase. And if the iteration it is going to increase, it means that it is going to take the more time to calculate the thing, more space to calculate, and we require the huge thing here because this is only the linear iteration method. It is the linear, it is going to be there. What is the exact condition? The Gauss-Seidel method converges if the number of roots inside the unit circle is equal to the order of the iteration matrix. This is also the one of the thing which we have to consider whenever we have to use this Gauss-Seidel method. So how it is going to be there? Okay, comparison of there is a one another method also, Jacobi method, and it is very much similar to the Gauss-Seidel method. But the Gauss-Seidel it is the one of the means we can say advance of that. It is the Gauss-Seidel method is more effective than this Jacobi's method because the maximum number of iteration required to converge and accuracy is less than other things, and it is good than this Jacobian method. Now, what exactly we have to do? Now, whatever we have talk of up till now, it is the only theory of this. What are the advantages, disadvantages, and other things. Now, when we are actually going to the system, we have to consider much more thing. This portion, okay, this you consider this as an angle. Okay, delta is an angle. Okay, del is an angle. So you know, because we have to consider the voltage and its angle of every bus. Now, as we have to start with the bus system, so we will start with the minimum, and then we will go to the maximum also. So first thing it is that we will go with the two bus system. In this system, what you can see, there are the two buses are there, bus one, bus two. On the bus one, we are connecting a generator. Generator means this is a AC generator, synchronous generator. It is there, and on the bus two, we are connecting the load. Okay, there is no other things here. It is a so simple thing. And connecting to the bus 1 to the bus 2, we are using the transmission line, and we are considering only the here the reactance, whatever it is there, we have to lump it, and we have to take into the consideration. Now, when I'm using this generator, we connected to this bus, we have to name it properly. So we will name it the V1 at an angle of del 1, then V2 at an angle of del 2, whatever the difference will be there. And we are actually feeding to this. Now, what is our objective in this thing? Now, in this, it is a very much simple as this is a normally the load it is given. What is the value of the load? So not it is called as so it may be in the form of x plus ij. Sorry, it is um, yeah. The load it is there. It is in the complex form, and here here there is no resistance, so only the value of the mm, reactance will be there, and as it is the value of the reactance, that is nothing but the value is similar to the its impedance. So impedance, this is the impedance of the line. We have to take into the consideration here. Then what we have to do, many times it is happened that we have to calculate the v1 and del 1, or we have to calculate the v2 and del 2. Most of the time v1 and v2 it is not known, and the delta del 1 also we have to calculate. So to calculate, if we had to put the equation, it is very much easy. If we want to calculate the equation of the current here, so equation of current, if it is the uh, now see this is the system. So so when the current is flowing from this bus 1 to bus 2, so there is a reactance it is there, and the same current it is going to the load. So we name it something that, let's take an example, we take as the I2. So if it is the I2, what we have to do, it is nothing but the V2 minus V1 divided by, we can say the V1, sorry, V1 minus V2, and whole it is divided by whatever this Z. So Z. I will write Z only so that you can able to get everything related to this. Okay. So what is the voltage? And so what is the current? The current it is given by this formula V1 minus V2 divided by Z. It is a so simple formula, whatever we are using. Okay. So when it is there, now if I want to calculate I2, so I have to do this thing. Now if I want to calculate what the value of the V1 and V2, if the V1 anyone out of that V1 and V2 it is given. So by formula, what we find, if it is the V1 calculation and V2 is given, we have to calculate the V1, and V2 actually at that time it is given, then it is very much easy if we do the calculation. But if it is the V2 we have to calculate and V1 is given, it is somewhat tedious to calculate, because there are the two types of the V2 is going to come, which is in the equation, and whatever we have to find out there also, it is the V2, it is there. As there are the two times V2 it is going to come, the equation is not so simple and cannot be calculated very easily. That's what we have to, we need some system to calculate it, and that's what we are using the Gauss Seidel and this type of the method to calculate the values of V1, V2 and anything. Okay. Any question related to this?
No, sir.
Okay. Now, okay, this is the explanation. The state variables what we have to calculate, it is actually state variables what we have to calculate, it is the 4, as I have told you. So number of buses are 2 multiplied by actually 2, so it will be, it comes 4. ये जो formula है, that is universal formula. State variables, they are number of bus multiplied by 2. So here 2 multiplied by 2, 4 will be there. And what are the parameters? V1, V2, del 1, del 2, we have to calculate. The load values are given. It is very much easy. One thing which I forget to tell you, that all the values are in per unit system. Okay. And initially the guess, the value of the variable, this is very important for number of iteration. If we are, our value, whatever we are guessing, if our guess is going to be wrong, then it is really very much difficult to get its answer. So to avoid it, means this is one of the disadvantage of this method also. Now, if we increase the one more bus, what is going to be happen there? Now, as you know, in the previous case, what we have taken, this is the system only. Now, only this system it is we have increased. Only we have to put there. Now, what you find from this? It is just like our previous case only. Only there is a additional bus. It is going to be there. Additional bus, again additional transmission line will be there. Additional load will be there, and the generator, it is a single generator. So you can say there is a radial system. It is going to be there. Okay. Now in this radial system, or in this system, what we find, the bus number 1, 2, 3 will be there. The bus number 1, it is connected with the generator, so this becomes a slack bus. You will find the V1 at the del 1, V2 del 2, V3 del 3. The load it is there, the load values will be there. You check the some values, random values can be taken. Um, and the calculation should be done on that. Whatever the impedance of the line, we have to consider the impedance Z1 will be here and Z2 will be here. Now, as number of buses is going to increase, you will find the complexity it is going to increase. Variable also it is going to increase. Now the variables are not only 4, it is going to increase from 4 to 6, because as there are the 3 buses multiplied by 2, so 6 as a 2. Why 2? Because it is the, we have to calculate the V1 and its angle, voltage and its angle. बस का जो निकलते हैं वो क्या निकलते हैं, वोल्टेज और उसका एंगल निकालते हैं. We are not going for the just now for the power and other things. Just to introduce this, I'm telling it. I will tell you this afterwards also how to calculate the power in that. Wait. So first it is we are going for the voltage and its angle. Okay. So when it is going to when we have to calculate the voltage and this angle, it is very important to know what exactly we are means how we are to calculate what method we are actually using. So to reduce it, as this is a slack bus, so we are considering. So we must know the values of V1. V1 we have to consider, and as the slack bus, normally del we are taking 0. Okay, एंगल जो होता है वो हमेशा 0 लेते हैं, but it is not compulsory it should be 0. One thing you have to remember, आपको ये याद रखना है कि this value it is not always 0. It is only the reference value, and that according to that reference the other values are going to change. So as we have to take the reference, this as a reference, so normally this is going to be taken as a 0, but it is not mandatory to take it 0. The voltage value it is there, and as we have to calculate the base kVA and other things, there we need a voltage or the maximum voltage there. Sorry, maximum kVA of the system. So at that time also this voltage and current it is going to come into the picture. We will see when there are the n number of the generators also connected in the system. Okay, so here you will find the V1 and V1 del 1, V2 del 2, and V3 del 3. So to calculate here, as I have told you, state variables it goes to the 6. Then the load values are given. It is easy to calculate if it is we can easily calculate the unknown variable. This is going to be in the form of the matrix I equals to y bus multiplied by the voltage bus, sorry, voltage. Then I of k can be calculated with this formula. Now, if instead of uh, load, the generator is connected, what will happen? Okay. Similarly, as the previous, there is no problem for this. In the bus number 1, generator, transmission line, bus number 2, and connected to the load, again transmission line, and you will find there the bus number 3, where another generator it is there. Now, when there are the two generators, we have to see the direction of current also. You have to remember this. Now, as the bus number 1, as we have taken, that is a slack bus. This is a slack bus. What we have taken, we can take any bus as a slack bus where the generator it is there. But as in this case, we have taken this. Uh, then this is the load, as there is no generator, so and no other thing. So we call this as a load bus, and this is the line. Now, what in this case also? As the we know the this is a slack bus, the voltage and angle it is known to us. It should be known to us in this case. Now, in this case, as although the generator it is there, we can control its voltage only. Remember, we can control its voltage. We cannot able to control its angle. इसका जो एंगल होता है that we cannot able to control. This is controlled by the system only, and we have to calculate it every time. But we can control the voltage one. Okay, how much voltage to be injected into the system, that we can able to calculate. The similar to that, and whatever the system I have told, what is the whatever I have told you, it is written here. For more than 3 bus, the voltage can be calculated in this way. One thing, voltage can be calculated. Normally, we are taking the Y bus because it is very much easy. We do not take the Z bus. And then there are the other things that's like the real power and reactive power. there the P and Q it is given, and accordingly we can able to calculate the voltage of any bus. Okay. Uh, any doubt up till now? If there is a doubt, you can ask me now. Okay. Hope there is no doubt, and you are going to get everything out of this. Now, when should we move to the next method? Is anybody there?
Yes, sir.
Okay. Now, as we are moving to the other method, that is nothing but the Newton-Raphson method. This is another method which is normally we are using for uh, the calculation of the load flow. Uh, this is the most used method previously, because at that time this is the method which is going to get the less iteration than the Gauss-Seidel method, and accuracy also it is very much high rather than the Gauss-Seidel method. Uh, it is actually based on the Taylor series and partial derivatives. So there is we must know this what is the Taylor series and how we can able to calculate this partial derivatives. Uh, and in this we can able to find out the roots of real value function, that is the f of x equals to 0, which is very much easy for us. What is the advantage? These are the advantages. The advantage of this method, it is the less number of the iteration to reach the convergence, take less computational time, more accurate, and not sensitive to the factors such like slack bus selection, regulation, transformers, etc. And the number of iterations required in this method is almost independent of the size of the system. The size of the system, as what we have seen in the previous in a Gauss seidel, if the number of buses are going to increase, or variables, state variables are going to increase. If the state variables are going to increase, our all the system calculation it is going to increase. If you want to solve the only 2 by 2 matrix, it is very much easy. But if you want to solve the 10 by 10 matrix or more than that, because the system, the buses are going to increase, then the matrix size is going to increase. And as the matrix size is going to increase, it is going to hamper everything. But not in this case, this is independent of the size, whatever the small size or the big size. So normally we are using for the different or the higher size size system, where we can able to get the uh, this value very early. What are the disadvantage of the system? More calculation is involved in each iteration and requires large computational time per iteration and large computer memory. As we know, we are not doing this calculation nowadays because we are putting different softwares. And, if you want to do a project also, you can able to find there are the uh, different softwares are there, just like a MATLAB. You can write any program on that, and you will get able to get its value. Okay, then as it is an iterative method, we have to put the one value and replace the previous value with a new one, and the last value will be the you can find if we are going if your iteration it is going to give the one value only, वही value बहुत बार आ रही repetition हो रहा है, so we can call it is going to converge. Normally it is the technique. Okay, The programming of this Newton-Raphson method, it is somewhat tedious, or it is a difficult. And if the derivative it is zero, uh, then this method is not going to work on that. If the system derivative or the variables derivative it is there, if it is going to be a zero one. Normally, if it is a constant, then it is going to be a zero one. So this, if it is there, then this method it is not going to work, and this is what it is having the different disadvantage. Now, if we compare the three methods, Gauss-Seidel, then Newton-Raphson, and fast decouple method. And this is the difference point. There are the 5 points related to this. It requires Gauss-Seidel. It requires the large number of the iteration to reach to the conversion. Require less number of the iteration to reach the convergence. Then require more number of the iteration than the Newton-Raphson method. But advantage also it is there, and some disadvantage of these systems also it is given. Computational time per iteration is less. Computation in the Gauss-Seidel, computational time per iteration is more in the Newton-Raphson, and in this the computational time per iteration it is less. Uh, then it has a linear convergence characteristics. Then it has the quadratic convergence characteristics, which doesn't depend upon both of that. The number of iterations required for the convergence increases with the size of system, what we have discussed just now. This is independent of the size, and this is also independent of the size of the system. This is what which is the most advantage part of this system. Here, Gauss-Seidel, it requires a very less memory of the computer and the calculating devices. More in a Newton-Raphson method, more memory is required, uh, and in the fast decouple method, you can find it is the less memory required than the Newton-Raphson method. This is the two methods which we have discussed for the load flow calculation. If anybody having any doubt related to this, please do ask me. No doubt? Okay, wait a minute. Okay, shall we move to the next topic?
Yes, sir.
Okay, now the next topic it is the voltage and frequency control. Now it is really very much important thing. Now what happened? Uh, when we are actually feeding to the one system, so this is the one. Supposing this is the one system in which we are actually whatever the we have in the previous. This is a system. Now, what happened? This is a generator, and we are actually increasing the load. As we are increasing the load, what happened? the load as it is going to increase, the voltage of this it is going to decrease. Okay, as we are increasing the load, the voltage it is going to decrease. Why it is going to decrease? Okay. As we are increasing the load, it demands the more power to be connected there, and if the generator cannot able to give the supply that power, then the voltage it is going to decrease. If we say this as a constant power generator, if it is feeding to the this uh, load and we are increasing this load steadily, then what we find that it is going to decrease the voltage. As the voltage it is going to decrease, there is a load on the generator, and that generator it is going to reduce its speed. किसी भी सिस्टम के ऊपर अगर कुछ लोड ज्यादा आता है तो इससे सिस्टम क्या होता है, you will find the speed it is going to decrease. As the speed it is going to decrease, according to the Faraday's second law, what we find, if the d phi by dt it is less, then the voltage generation it is also less, and if the d phi by dt it is less, or the number of the frequency also it is going to hamper. This is what we find when we are going for the voltage and control on voltage and frequency. Now, as what we want the constant voltage and constant frequency. The whole variation in a frequency should be very much less. Normally, this frequency it is fixed to the 50 hertz, and the variation it is only of the point 0.5 it is given. Okay, normally previously it is a 5%, so it is 2.5 less or 2.5 more, it is uh, it is admissible. But nowadays it is not the case. We are actually going for the power quality. If we are going for the power quality, we have to put the frequency very much constant. To put the frequency very much constant, if we can able to put the frequency constant for the generator, then the voltage also it is going to be a constant one. Now see, if the as we in the previous case we had taken the generator and the load. Now what happened? Whatever the load it is going to be increased, we have shut down all that load once. If we shut down the load once, what is going to happen? There is no load on the system will be there, and the speed of the generator it is going to increase. As the increase in the speed of the generator will be there, generator generator speed depends upon the turbine speed. Normally, there are the two types of the turbines. One it is the steam turbine, and another hydro turbine. Most of the generation it is on that only. So if the load it is less, then the turbine speed it is means suddenly the load changes, then the speed of the turbine it is going to hamper. As it is going to hamper, its voltage and frequency it is going to change. So what we have to do? We have to monitor its voltage and speed. To monitor its voltage and speed, we must go for the automatic speed controller, automatic voltage controller. For the automatic voltage controller, there are the different systems are there. We are not going to discuss that system here. Only you remember this thing. If we have to control the voltage, then the frequency, voltage and frequency, we have to use the constant speed motor will be there. Sorry, generator should be there. For that, the turbines should be whatever the turbines we are using. It should be automatically adjust its speed according to the requirement. And if it is there, this okay, we will escape this. Hmm. Now, what exactly it is going to be there when there is a change in the load will take place? So this is a generator. Generator, it is going to be run by the turbine, and turbine is going to be run by the steam or water. Okay. Now this is a load. Okay, which is the most variable thing. Varying thing considering only the electrical load. Now, as the load is going to change, it is going to put the pressure on the generator. According to that, it is going to apply some pressure here, that turbine, and that turbine, to get the speed, we require some mechanism, and this is that mechanism. And what we want, the frequency should be constant, so we are sensing this frequency. The previously set frequency should be there. Just take an example. If we want to generate anything here in electric in India, the frequency, it is a constant one, that is the 50 hertz. Okay, and Europe and other places, they are using the 60 hertz, but for India we are taken the 50 hertz. So 50 hertz frequency, and whatever according to the our frequency, if there is a deviation, it is there. That deviation del f, it is there. Delta f will be there. That it is going to the controller. That controller put the some signal to the speed governor. Whatever the change, or whether it is to be a positive or negative, whether we want to slow down the turbine, or whether we want to increase the speed of the turbine, that is going to be calculated here. And whatever the difference it is there, it is given to the hydraulic amplifier. Hydraulic power, it is going given to this, and then whatever the output it is there, the amplified output it is there, it depends upon it is going to change its wall position. Wall position, wall, I hope everybody is knowing this wall. According to the wall position, the steam, it can be controlled. It is just like the mm, accelerator in our way to two wheeler. Okay, एक्सीलेटर इन एवरीवेयर इट इज देयर. एक्सीलेटर का जो काम होता है स्पीड कम या ज्यादा करने के लिए, जो वट एवर वी आर यूजिंग, और दिस टाइप ऑफ द थिंग इट इज गोइंग टू बी यूज्ड इन दिस wall. So wall, it is there, the steam or the water will be there, and this is going to be this is going to control the speed of the turbine. Okay, that shaft again, whatever the shaft of this, it is actually connected to the hydraulic amplifier. This power, what the difference in the speed, it is again calculated, and this is going to form a closed loop. Now, what exactly happen if the change in a current is going to be there? Now there are the two types of the change. One we expecting one higher load, and we will take the lower load. The mean between, there is no problem about that. It is the normally we are taking the maximum or the extreme cases we are taking. So first case we are taking when the sudden load changes to the its maximum load. What is going to happen if the load is going to change to its maximum? So it is going to exert a much more load or much more thing on the generator. As it is going to exert something on the generator, that generator is, means its speed is going to drop down. This is going to be sensed, whatever it is there, it is going to be sensed by this turbine. And this turbine, again, the whatever the speed, they again, it is a closed loop, primary control loop will be there. The speed, if it is very much less, then it is sensed by this, and it is going to open the gate of this wall. If the more steam or more water is going to come, means as we require, the more power should be given. So we require more steam, or it is the steam turbine. If it is a steam turbine, it is the steam, and if it is a hydraulic or the water turbine, the water it is going to flow. So we are going to open the valves accordingly. So we are can able to maintain this primary loop if the higher speed it is the if the low speed it is low. So if the load it is now what happened, it is the system is operating properly, and take this case 2, suddenly the load is switch off. Suddenly the load is switch off. Again the same condition, what is going to happen, the load it is switch off, means there is no actually burden on the generator. So the generator speed is going to increase because there is no burden. So it is because of the turbine. It means that the speed of the turbine it is going to be higher one, and again it is going to sense by this amplifier. This is also done by the secondary loop, because as the frequency as its speed of the generator it is going to hamper, it is hampered to the frequency. If the generator speed is less, then the speed frequency is going to be less. If the generator speed is high, the frequency it is going to be uh, high one. This type of the problem is just arrived in the recent days, when our prime minister had said that we have to switch off all the lights. Uh, at that time, as there is no industries are working, so this is actually a very problematic situation, or it may convert to the uh, blackout situation. But our power engineers had worked in such a good way that they have actually controlled everything. But as we got the 2 or 3 days for that, it is very much easy for us to control also. But there are, but on the power system, if there is no load, it is really very much difficult for a power engineer, because only light load it is there at that time. But and light load is only there, and if it is also going to be switch off, then the power system or the transmission line cannot be switched on so early afterwards if it is a 0 1. So at that time some instructions also given to the many things, that you have to start something for that much period, 10 minutes periods are it is there. And they have started, and we are come up with this with that situation, come out from that situation. uh, Anybody having any doubt related to this? Any question? Okay, if you have a doubt, you please do ask me so that I can able to clear your doubts. Now we are moving to the another portion. Okay, that is nothing but the power factor correction. Now what is the power factor? This is now very basic question, and most of you also know, you have studied in a EPS one. They had done some calculation on this, and that is only it is for our study. So what is the power factor? It is nothing but the cosine of an angle between voltage and current in an AC circuit is known as a power factor. So this is our voltage, and this is our current. So whatever it is, the angle between this, and if we have to calculate, this is the angle, and that is nothing but the if we take the cos of phi, then it then we call it as a power factor. Now, what is the power triangle? Okay, similarly to that, it is the power triangle. It is there, as in the previous case also. What we have seen, it is the angle beside this, sorry, the line beside this, and if we are multiplying with the hypotenuse, then it is going to be a the side, this side will be the opposite side. It is a sign. So it is this is a sign of the angle, and this we have to calculate in this. Yes, this is we can able to get in this case purely. Now this is the angle. Normally the voltage, it is the power factor angle. We will say, or the power factor. The OA, it is nothing but the VI cos of I. It is nothing but the real power or the active power. It is normally given in a kilowatts, which is which is uh, used by us. Another, it is the AB. This is AB. So VI sin phi. This is nothing but the reactive power measured in a VAR or kVAR. Remember, the K in this case it is small. Most of the time, the student forget to do this thing. Okay, so the K it is a small, means for the K it is only for the kilo. So kVAR, this is a unit which is we are normally using for this. Now, this OA portion, it is nothing but the, it is called as a apparent power, which is given in a VA or a kVA. That is